Assalamualaikum and welcome to my video. My name is Muhammad Naim bin Azhari. I am final year student of Mechanical Precision Engineering under the Faculty of MJIT. In this video, I will present my final year project with the title of Hybrid System of Rainwater Energy Harvesting under my supervisor, Dr. Hafizah Yahya. Energy is essential to life and living organisms on Earth. However, our world is demanding more and more energy for human organization. Hydropower energy becomes one of the essential energy sources. When water flows through any types of turbines, kinetic energy generated will be converted into electricity. Meanwhile, hybrid power system is the combination of two or more technologies for higher efficiency compared to single power source. Hence, this research will be discovering a hybrid Francis turbine by optimizing normal Francis turbine with a transducer which is a piezoelectric. The objectives of this research is to design and fabricate hybrid Francis turbine using three-dimensional printer and a complete electrical circle that combines both output voltage from motor and piezoelectric film into a single output voltage. Next is to measure the output voltage and study the effect of the following parameters towards the deflection of piezoelectric and its output voltage. The first parameter is the number of stoppers mounted at the shaft, second is the inlet angle of Francis runner, and the last one is the distance between the tip of the piezoelectric film with the tip of the stopper. The last objective is to produce a hybrid Francis turbine that has higher efficiency than a normal Francis turbine and determine its optimum settings based on the parameters. The fabrication of the components of Francis turbine were using 3D printer. For electrical circuit, the motor and the piezoelectric film were connected in series as shown in the figure below. The toilet flush tank were used to provide high pressure of water into the inlet of the turbine. The piezoelectric was placed near the stopper where the stopper was mounted on the shaft. For hybrid Francis turbine, piezoelectric film was used as shown in this figure, while for the normal Francis turbine, there will be no piezoelectric used, just like this shown in this figure. The measurement of output voltage are by using oscilloscope based on the following parameters. The distance between the tip of the piezoelectric film with the tip of the stopper on the rotating shaft will be used as 6 mm, 12 mm, and 18 mm. Next is the inlet angle of Francis blade runner. The angle that will be used are 45 degree, 60 degree, and 70 degree. The last parameter is the number of stoppers at the rotating shaft hitting the piezoelectric film. The number of stopper that will be used are 2 hand stopper and another one is 4 hand stopper. To calculate the turbine efficiency, which is to determine the most efficient settings, this final formula was derived from the hydraulic efficiency formula. This derived formula requires average current and time, or period of blade runner rotation. The average output voltage will be converted into average current using first Ohm's law V equal to IR, and the period of rotation is the period when the shaft starts rotating until it stops. These are the fabricated components of Francis turbine using three-dimensional printer. Some of the components, such as Francis runner, wicket gates, spiral casing, and draft tube, were fabricated precisely and had smooth finishing. The result of this research can be seen on this slide. The graph shown is one of the graphs of voltage output generated by the oscilloscope from the experiments. As shown on the graph, voltage mean are the values of voltage that are only be taken into the calculation of turbine efficiency, while period T was the period of the rotation of the runner, or the shaft connected to the runner. All the data for output voltage were converted into the efficiency values and were simplified into this bar chart. As we can see, the higher the distance between the tip of the stopper and the tip of the film, the higher the output voltage. It works for all the angle plate runner and the stoppers. As you can see, the 18 mm distance has produced the highest efficiency compared to the others. Next is the period of blade runner rotation according to the number of the stopper. By increasing the number of stoppers, it will cause the period of rotation to become shorter. It works for all angle blade runners. The 70-degree blade runner produced the longest period, while the 45-degree blade runner was the shortest period. As shown in the slide, N15, which is referred to 70-degree blade runner, two-hand stopper and 18 mm distance, has recorded the highest efficiency for single piezoelectric, while N4, which is referred to 45-degree blade runner, four-hand stopper and 6 mm distance, has recorded the lowest efficiency compared to the others. A simulation done by Ayanchi et al. 2013 has found the optimum inlet angle was 66.7 degrees. This has verified our finding that 70-degree blade runner was the optimum angle. By comparing the turbine efficiency with the use of single piezoelectric with the one without piezoelectric, it shows a significant increment in the efficiency. When using double piezoelectric, it shows higher efficiency compared to the single piezoelectric. For conclusion, firstly, this research has successfully fabricated all the components using 3D printer and built the electrical circuit that combines both piezoelectric and motor input voltage. The best settings of a hybrid turbine with the use of single piezoelectric is by using 70-degree blade runner with two-hand stopper, and the piezoelectric film should be mounted 18 mm distance between the tip of the film with the tip of the stopper. The efficiency of the turbine when using double piezoelectric film has doubled compared to the one with the single piezoelectric. Technically, this research has successfully produced a hybrid Francis turbine with a higher efficiency compared to the normal Francis turbine. That's all from me. Thank you.